Okay, Unit 6 review, picking up from problem 13. These next questions are asking you to do the reverse of what we just did. So the last question was all about expanding. This is about taking something that's expanded and smushing it together. So when I see something like addition, I want to rewrite that as a multiplication statement. When I see multiplication of something like a constant in the front, that can be an exponent. So here are my answers for question 13A and B, right? My numbers in the front became exponents. And then when I have addition, that is going to become multiplication. In this next couple, again, I have a multiplier here, so that's going to become an exponent. Multiplier, multiplier, those are going to be exponents. When I have subtraction, that's going to be a division statement. And when I have addition, that's going to be a multiplication statement. And so we should have something along these lines. If you get confused about things, like places where I would expect there to be maybe some errors on this are, first of all, you need to make sure that you recognize that the 1/4 applies to all of this, right? So this 1/4 is an exponent on all of that. So you might actually have written this in a slightly different way, and it would still be absolutely correct. You might have written 5x all to the 1/4 power. That would be awesome. That's a correct answer. All right, just a different format. In D, notice that I'm working from left to right. There weren't any parentheses. So this subtraction becomes the division statement when I still have this addition. And then this expression, the x over y squared, is going to be multiplied by the z to the third. So just keep things kind of organized. Don't try to do too much in one step. Okay, this question mentioned using the change of base formula or other log properties to try to rewrite it in base 10 logs instead of base 3 or base b. So if you know the formula that I'm referring to, awesome. And if you don't, this is what I would do. And I'm going to show you kind of like the figuring it out way, because sometimes our memories are not all that we want, right? And so if you need to figure out what this is in base 10, you could just say, well, let this expression be x, the thing I want to know. Let's rewrite this in exponential form. Let's take a base 10 log of both sides. And then I could use my down and front rule, right, my log properties, and say x times the base 10 log of 3 is the base 10 log of a. And then to solve for x, the thing that I am looking for, I would divide. So if you go back to the start now and say, all right, that's what I called x, and x at the bottom of my problem is equal to this expression, then this kind of tells you what the change of base formula is. So you can see, even though I started out with base 3, I can rewrite it with a different base. I can rewrite any log with a different base, and the thing that's here is going to go here, and the old base is going to go there. So with that idea, I could say, well, this is going to be rewritten with base 10, and the base that was my old base is going to be this, and the other number is going to be, or expression, is going to be the part that's on top. Okay, so that is what you should have. And understand, right, you can just do this in one step if you actually know the formula, but if you don't, you just do what I just did, right? Refigure it out. It's possible. All right, so 15 has us solving. Now, these are both exponential equations, and if I could write them with a related base or the same base, I certainly would do so, because that's going to make my life a little easier. But if I can't, then I just have to jump right into logs. So I'm going to choose to use a base 10 log because that is on my calculator keyboard, which makes it a little easier to access. Okay, so just take a base 10 log of both sides. And if I don't write a 10, the default is base 10. I'm just doing that for emphasis right now. I'm trying to find out what x is, so I could bring x down in front. This looks a lot like what I just did on that change of base question. And then I would just be dividing to get my value of x. Okay, and I can get that off my calculator. On the next question, I actually can write these with related bases because 8 is a power of 2. I don't know if I want to write it that way. Hold on, sorry. Trying to think of what would be the most clear. And 16 is 2 to the 4th. So all I did in that move was I replaced the 8 with 2 to the 3rd, and I replaced the 16 with 2 to the 4th. Okay, I didn't do anything other than that. Just did a replacement of equivalent things. All right, so then if I have a power to a power, I multiply. And that's the same thing here. I have 2 to the 4th and also 2 to the 3x minus 2. So I'm going to multiply, which means distributing that 4. Now I have an equation with equal bases. So that means the exponents have to be equal. And now this just turned into an Algebra 1 question, right? Move the x's to one side, divide, blah, blah. Okay, so here are the rest of those answers. Okay. Oh, you'll notice that it did say over here, because it said exact values, I left my answer in terms of logs. I didn't go push that into my calculator, though I could if I needed a decimal. Okay, for C, I want to consider if those are related bases. And they are not, even though it kind of feels like they should be, like they're both even, but that doesn't mean they're related by like powers, right? So I'm going to be using logs on this one. And the same thing is true of D. Now, both of these questions are actually very hard. So your teacher might not have even assigned them. I am just going to let you take a look at these solutions. Just so you can appreciate how complicated they are, I guess. Chances are, yeah, I don't know. So I'll just let you look. I'm not going to talk through them because I'm pretty sure that your teacher probably just said to not do these two problems. Okay, and we'll do one more on this video. So question 16 said, what is the solution of this equation? So to solve, I am going to divide both sides by 3, and I'd get 4 to the x plus 1 equals 12. And then I'm going to use logs. Take a log of both sides. I'm kind of keeping an eye on my answer key, or my answer choices here. They all mention log base 10, so I'm going to utilize that. I just used a log property to bring that exponent down in front. And then I'd have x plus 1 equals the log of 12 over the log of 4. And then I would subtract 1 from both sides. At this point, you might panic. Don't panic, okay? It's just, you don't really necessarily see your answer here right off the bat, but you need to go to your calculator because one of these is equivalent to having log of 12 divided by log of 4, find that answer, subtract 1. So you just check with your calculator. And my expression that I just had, my expression that I just mentioned to you is 0.792. And then I went to my answer choices and figured out which one was also equal to 0.792. All right, so there's going to be one more video going over the rest.